Lesson 14.2, Task 1. Express geometric sequences explicitly. Recall that an explicit rule for a sequence defines the nth term of a sequence as a function of n. You can write explicit rules for geometric sequences. Karen shares a funny video on social media, and the video is viewed 10 times the first day. Each day during the rest of the week, the video gets 3 times the number of views as it did the day before. Alright, so in the video, or in the picture, you can see Karen's video is viewed 10 times on the first day. And the first question says, let V of n represent the number of views on the nth day. This function defines a sequence. Which statement regarding the sequence are true? Select all that apply. So it says the first 3 terms of the sequence are 1, 2, 3. The first 3 terms of the sequence are 10, 30, and 90. So this one seems more reasonable. If there's 10 views on the first day, and then 3 times that many the next day would be 30, and 3 times that many the next day would be 90. So this is one true statement. And it says the common ratio is 20. Is it 10 times 20 gives me 30? No. So the common ratio is 3. That is true. 3 times 10 is 30. 3 times 30 is 90. So the common ratio would be 3. Alright, it says the table shows V of n expressed as the number of views on the first day multiplied by the common ratio a number of times. Complete the table to show the number of views on days 4 through 7. So you can see the pattern. It has 10 times 3 to the 0 power. Anything to the 0 power is 1. So 1 times 10 is 10. 3 to the first power is 3. 3 times 10 is 30. 3 squared is 9. 9 times 10 is 90. So the next one we need to have is 3 cubed, which is 27. 27 times 10 is 270. So we need one that says 10 times 3 to the third power equals 270. Alright, 3 to the fourth power is 64? 84. 81. I don't know what I'm thinking. 9 times 9 is 81, and 3 to the fourth is the same as 9 times 9. So 81 times 10 is 810. So we're going to have 10 times 3 to the fourth equals 810. And then 3 to the fifth power is 243. 243 times 10 is 2,430. And then 3 to the sixth power is 729. So multiply that by 10, and that gives me 7,290. Alright, so you do need to check those because as you can see there's 3 to the third and 3 to the third. There's a couple different selections to put in there. You do have to make sure you evaluate the answer to get the correct one. Alright, it says which expression can be used to find the number of views on the nth day. So we can do 10 times 3 raised to the n minus 1. As you can see, the 7th term is 3 to the 6th times 10. The 6th term is 3 to the 5th times 10. So the exponent is always 1 less than whatever n is. So it's going to be 10 times 3 to the n minus 1 power. Alright, that's all for task 1. If you have any questions, please let me know. Lesson 14.2, task 2. Express geometric sequences explicitly. The general explicit rule for a geometric sequence. Alright, so this is important to know. Make sure that you have this rule in your notes, the name of it and the rule itself. So it says an explicit rule for a geometric sequence with common ratio r is given by f of n equals f to the first This just means your first term. F of 1 is just your first term, times r, your common ratio, raised to the n minus 1 power. So for each explicit rule that you write, this is what you're going to write it as. F of n equals your first term times your ratio raised to the n minus 1 power. All right, so it says consider the geometric sequence 125, 50, and 20. So what is an explicit rule for this sequence? Well, we can see that f of 1, our first term, is 125. Each of these has the same first term, so that's not enough to help. We also have to find the common ratio. So what is the common ratio? The common ratio is what you have to multiply to get from one term to the next term. So if you have to multiply to get from one term to the next term, then you're going to divide to get from here to here to see what it is. So you can say, what is 50 divided by 125? And if you pull up the calculator, you can see that 50 divided by 125 is 0.4. We'll go ahead and check the next one. So 20 divided by 50. If it's a common ratio, it should have the same ratio. 0.4 it does. So both of these have a common ratio of 0.4. That means that our R equals 0.4. All right, so that we know the first term is 125, we know that it's 0.4, and we know that it's going to be raised to the n minus 1 power. So this one is the only answer that can be correct. All right, and if you want to multiply, you can do 125 times 0.4. You're going to get 50. 50 times 0.4 is 20, and so on. So that's why we divided, because division is just the opposite of multiplication there. All right, it says complete the statement. The domain of the function is a set of. All right, so what numbers do you put in for n? You put in 1, 2, 3, 4. So that's the set of not all real numbers. We don't put negatives in. We don't put fractions in. So we're going to put natural numbers in for our domain. Remember, domain are x's. That's the number that we input in the function. All right, the geometric sequence is equivalent to an exponential function with a restricted domain, which shows the explicit rule for part A written as an exponential function of the form f of n equals ab to the n power. All right, so let's just do a little bit of math here. So we have our rule that we're given is f of n equals 125 times 0.4 to the n minus 1 power. All right, and we want to write it as a form to the n power, not the n minus 1 power. So let's see if we can manipulate this equation just a little bit. So what does it mean to have 0.4 raised to the n minus 1 power? So I could have this to the n power times the negative 1 power. All right, when they have the same base, you can add exponents. Okay, same base, add exponents. So we added n and -1 to get n minus 1. So if we separate those, this should work. So we're going to have 125 and then 0.4 to the n power. And now let's evaluate what is anything to a negative exponent is going to be 1 over 0.4. So that would just be to the first power now. And what is 1 divided by 0.4? 2.5. So 2.5 times 125 is 312.5. So if I multiply this number here times this number, because I don't have an exponent or a variable now, I can multiply those together, and I get 312.5 times 0.4 to the n power. Alright, so if we look here, if we want to write it in the form of Fn equals AB to the n power, this is exponential form, remember. This is our y-intercept, this is our growth or decay rate, and this is our exponent. So AB to the n power would be 312.5 times 0.4. This would be a decay factor, and that would be your exponential function. All right, that's all for task 2. If you have any questions, please let me know.